All right, welcome everyone. So my name is Eldon Christensen, and I'm program manager on the Windows Server High Availability team. So I own the failover clustering feature that you see in Windows Server. I also own the networking load balancing feature that you see in Windows Server. And so what I'm going to talk about during this session is I'm going to talk about how to use technologies in Windows Server to enable your applications or your services to achieve high availability. And so I know it's like Friday, it's after the attendee party, it's after lunch. This is like every card is against me here. So I appreciate you being here. You guys are the hardcore ones. And I'll try to be nice and animated, or else this is one of those challenge sessions, right? It's like the end of the show, afternoon, everybody's thinking about their plane rides home or falling asleep from having lunch. So I'm going to talk about. I kind of got this in three parts. What I'm going to do here, and so I'm talking about how to use core services in Windows Server to achieve high availability. So I'm going to talk about a little bit about a clustering overview, a little bit about what is failover clustering, the technology, what do we provide, what are the components that we provide that can help you. And then I'm going to talk about storage, and I'm going to talk about how do we manage shared storage, and this is really important for anyone who has a stateful application. So I'm going to talk about how you can store your data on shared storage, how we manage it, how we move it from server to server, and I'm going to talk a bunch about cluster shared volumes. So if there's anyone in the room, which is kind of our clustered file system we provide in Windows Server. So I'm going to talk about cluster shared volumes. I'm going to talk about if you have filters that need to integrate with CSV. I'm going to talk about things like that. I'm going to talk about how to store up data on cluster shared volumes and how to integrate with cluster shared volumes, and how to interoperate with cluster shared volumes. And then at the end, I'm going to talk about how to make an application highly available. So I'm going to talk about things such as some of the in-box generic things that if you have a service or an application, how you can configure it for high availability using our in-box generic service and generic application resources. I'm going to talk about writing scripts with the Gen script resource to kind of get better levels of availability, and then also about writing resource DLLs which integrate into failover clustering to kind of get the best integration points if you want for your services and applications. All right, so let's talk about overview. So failover clustering, we're really targeted at stateful applications. So if you have a stateful application, failover clustering is usually the technology. So I'm going to flip forward for just a second, and I'll come back. So there's kind of, when you think about it, there's kind of two ways to go. For stateful applications, usually you want to go with failover clustering because my team owns two technologies. And if you want to talk about doing a stateless application, such as IIS or a web-based app, usually you want to think about using something like a network load balancer. So you might use a software load balancer that comes in Windows Server, My Technology Network Load Balancing. You might use a hardware solution, like an F5, right, to distribute those incoming connections across a set of servers, and that provides you both scale out and high availability. So if you have a stateful application, failover clustering is what you should be looking at. We are a feature integrated into Windows Server. So it comes with Windows Server. Failover clustering is available on all SKUs of Windows Server in Windows Server 2012. So in the past, failover clustering was a premium feature, was only available in the higher end SKUs, in the enterprise and data center editions. Now in 2012, we are available in all SKUs. So it used to be that in the past, that was always kind of a barrier for people saying, if they wanted to configure their service or application for high availability, there was a cost that came with that. But that's no longer true. We're in all SKUs, comes in Windows Server for free. I won't say for free, but for Windows Server, comes in part of the standard default feature set. Failover clustering works on industry standard hardware, so there's kind of a big misconception that failover clustering requires this big special hardware, and that's not true. And I'm going to talk about some of the different hardware configurations in a minute. So industry standard hardware on what you have today. And you can actually configure an app or service for high availability with little to even no changes to the application. So I'm going to show you how to take services and apps and make them highly available with no changes to them. And then we have an extensible model that you can plug in a wide variety of things. We have a lot of people that integrate into failover clustering today, so we have a large ecosystem. And then one thing that's interesting with failover clustering is that you can also make it a disaster recovery solution. So you can actually take nodes within a failover cluster, and traditionally you think of them being on the same location, in the same rack. But you can actually take one of those nodes and put it off in a remote location in another data center, and you can actually create clusters that span data centers so that in the event that one data center fails, things will automatically fail over to the other data center. So you can achieve high availability and disaster recovery with failover clustering. Let's see, I talked about this a little bit. So we're really geared at stateful applications, like SQL. Okay, I'm going to move past this one. So when do people use, what are the workloads most common with failover clustering? So failover clustering is used as the HA strategy and solutions within Microsoft for the Hyper-V workload, for SQL, Exchange, and file services, Windows file servers. Almost every Hyper-V deployment that goes out clustered and highly available. Exchange, almost every Exchange deployment goes out clustered and highly available. SQL, a huge percentage, and file server as well. My main point of this slide is I want to talk about is that if you are building applications or services which care about these workloads, you need to care about clustering and being interoperable and integrating with clustering. So that's my key point here is that even if you're not a person here saying, I don't really care about making my application highly available, maybe you're a backup vendor or an antivirus vendor. You don't care about making that highly available, but you do care about these workloads, and you do care about being integrated and interoperable with failover clustering so that you can work well and provide an add-on solution to these workloads. This is an eye chart, but I'll just kind of go through a couple different things. So what are some of the different things that we provide? So we actually have a plug-in model that we can allow these resource DLLs to plug into failover clustering and extend it. We provide start and stop ordering, so we can actually control start ordering of your application. So if you have multiple layers within your application, we can start and stop things in different orders. We actually have a replicated store. So we have a cluster registry under HKey Local Machine Cluster. We actually will keep the cluster hive, a part of the cluster database, replicated and synchronized synchronously across all the nodes in the cluster. So if you have state that you want to push around a set of machines, we provide a mechanism and a cluster registry API that you can actually push data into our registry, and then we will in turn go around and push it around all the nodes in the cluster. Also, if you change state, so if a user goes and configures your application or service on node 1, and you have a giant 64-node cluster, you can push those changes into the cluster registry, and we will push them around all the nodes and make sure the registry keys and state stays consistent, so they only have to configure it once. So we provide a lot of those functionality for you. What else is interesting here that I will talk on? We provide resiliency to a wide variety of both software and hardware failures. We can also do application level monitoring and give you integration that you can monitor your application and what makes sense for your application. So here's kind of the traditional cluster topology that's kind of existed for the last decade as kind of you know it. So here I've got a set of servers. I've got a redundant set of networking. So you can see here I've got two sets of networking. On the top, I've got the network which clients come in through. There's also, we usually want to have redundancy in the communication between the nodes in the cluster. So there's another network which is dedicated for internal cluster communication. And then here I've got some sort of shared storage. And I've got resiliency just in my diagram with some pair of switches. And this could be iSCSI or Fibre Channel or even SAS. And then there's shared data. And so the data on the back end down here is actually shared and available to all the nodes. And then we orchestrate access to the data. So what were some of the things that we did in 2012? So some of our focus of what we changed. So if you are familiar with clustering as it existed in the past from 2008 or 2008 or 2002, what are some of the changes that we made? So a lot of our focus in 2012 was around enabling the private cloud. So if you think about the private cloud, the Microsoft private cloud story, there's kind of three key teams that are at the cornerstone of that. Between, obviously, Hyper-V with the hypervisor. You've got the failover cluster team, which is kind of the distributed infrastructure. And then you've got SCVMM, which is then the management layer on top of managing your entire data center for the Microsoft private cloud story. So we did a bunch of features and integration. So we integrated with things such as live migration, storage migration. We introduced VM priorities, and it's all integrated in with failover clustering. We also want to scale. So when we started thinking about the private cloud, we want to provide a very scalable, robust platform. So now we scale up to 64 nodes in a cluster and 8,000 virtual machines on top of a cluster. On the storage side, we wanted to lower the cost of storage. So we integrated with Storage Spaces, which is a new solution here in 2012. And we also want to innovate cluster shared volumes. So cluster shared volumes, when it was first introduced was first introduced, I should say, in Windows Server 2008 R2, and it was only for the Hyper-V platform. And that's all we supported it for was with Hyper-V. Now, in 2012, it is now a general-purpose clustered file system, and we support any workload on top of it. So now, if you want to build an app and run on top of CSV, we will support that. And I'll talk about what that means. And I talked about already, we're now available in Standards Edition. So we want to provide the lowest total cost of ownership. So we now have clustering in the Standard Edition. So here's just like some of the. So Windows Server 2012 was actually a 3-year release. So it was a big turn of the crank for us in the development team. And we crunched out a lot of features in these 3 years. And so when you ask about what changed between Windows Server 2008 R2 and Windows 2012, it's actually like I could do like a 2-hour presentation just to do the high-level stuff. So here's just a quick snapshot of some of the stuff. I'm not really going to go into it. Oh, and if you guys have questions, please ask them as we go. Like, I'm open to having a dialogue, and I want to talk about what you want to hear about. So don't just let me give you death by PowerPoint here. So let's talk about storage. So there's just kind of a quick overview of what is failover clustering. Now let's talk about storage. So we provide an infrastructure to allow shared storage. So to allow a single LUN to be visible to multiple servers at the same time. And then we control access and ensure data integrity. So with NTFS, it's not a clustered file system, so we need to provide control over ensuring that the file system does not become corrupt by having multiple initiators, multiple servers touching the data on the server at the same time. And so that's one of our key initiatives that we need to provide. So we prevent the uncoordinated file access, and then we resolve ownership to make sure that there's a single owner of the volume in doing orchestration. So what does that mean? So we actually use SCSI-3 persistent reservations as a mechanism to ensure ownership of a LUN. So an individual LUN, we want to ensure that all access is coordinated, so it's done within the cluster. So we use persistent reservations as a fencing mechanism to ensure that only the nodes within that cluster can access that data and access that LUN. So that's the way we ensure coordination, and no one else coming outside. So you can do that with any block storage. So this could be Fiber Channel, iSCSI, FCOE, or SAS. So they're all supported with failover clustering. We support them all. So just kind of a quick thing. What is the actual hardware requirements for clustering? So the first thing is that you just go by any logoed device, any logoed server. So you make sure everything in the cluster is logoed. Server is logoed, storage is logoed, NICs are logoed. And as long as everything has a logo, we actually ship a functional test tool built into the product called Validate. What Validate does is it actually goes and ensures interoperability of all the components within the cluster. So it makes sure that things work well together. It makes sure that things are all wired up right, that you configured your SAN properly, that you have network communication, that you have resiliency, and it makes sure everything's all wired up. Validate passes, you're supported. And so you can actually mix and match and combine clusters out of any hardware. We don't have a predefined list of very special hardware that only works with this, and you have to pick things off a list. Pick whatever you want, as long as it's got a logo, run the test and it'll pass. So let's see. So for any storage vendors in the room, so if you were thinking about, I am a storage vendor, I am an IHV, and I'm thinking about supporting clustering, what does that mean? Well, I don't know of any storage array that really doesn't support clustering at this point because of our broad install point with all those. But I just thought I'd throw this up here for the people who are interested. The one thing I wanted to point out, so these are all the actual SCSI commands, what does it mean to be interoperable with failover clustering? So these are actually all the SCSI commands we use when we're doing fencing, all the exact persistent reservation commands. The one I just want to point out, actually, look at the pointer works. Okay. So down here at the bottom, we have a new register command that we use in 2012 when doing a clustered space. So this is actually a new flavor of the register command that we hadn't used in the past. So if you were a storage vendor and you go in, run the validate tool, we may throw a warning now, which we didn't in the past in 2008 R2. This register command is only used with spaces, and spaces is only supported on top of JBODs. So if you are a storage vendor and you have some sort of either hardware or software RAID, spaces is not supported on top of that. So you can safely ignore that. So this is my giant. If you are HP or EMC or NetApp and you are running this on top of your hardware RAID solutions, you don't need to worry about the warning which will be generated for this last command. So this is that's my disclaimer. This is only for spaces. And that's why we put it in a separate test, and it's only a warning. So, okay. So shared nothing. So prior to Windows Server, prior to 2008 R2, failover clustering implemented the shared nothing model, which meant that from all the way, since clustering's been around for over a decade now, we've been around since NT4, and what we did is in the past is that a LUN was only available and presented to a single server at a time. And then in the event that when we wanted to switch things, we would actually switch ownership of the LUN, we would dismount the file system from one node and then mount it on the other one. So here's kind of how that would work. So let me talk about what failover means. Actually, let me talk about that. So let me talk about what failover means and how we switch it. So here's a 2-node cluster. I got some shared storage. I have a SQL instance running on node 1, and this is passive running on node 2. My clients are up here, and they're connected to the SQL instance on node A. So you walk up and you yank that power cord out of the back of node A. What happens? Oh, it happens as I hit the wrong direction on the clicker. So failure occurs. You yank the power cord. What's going to happen is that we will break the reservation off of that disk. We will reestablish a new persistent reservation to this node. So ownership of the LUN will actually change. Then we will go and mount the file system on that node. Then we will go and start up the SQL instance on this node over here. And then clients will go and reconnect to this. We'll have to have reconnect logic and connect over to the SQL instance, which is now available on the other node. So that's kind of a quick high level. What does failover mean? That's what failover really means. And your service, if you guys have a custom service you want to make highly available, will fail over in the same model, and I'll show you it when we set it up. So how did things change? So in 2008 R2, I talked about we build cluster shared volumes only for Hyper-V. Now in 2012, we have CSV, and it's available as a general purpose clustered file system for all workloads. What CSV does is it provides orchestration of an NTFS volume. So under the covers, it is still NTFS, which is not a clustered file system. What CSV is it is an abstraction layer above NTFS where we are controlling access to files on the NTFS volume. Some of the value of this is that all nodes have access to a LUN. So in the past, the LUN was the smallest unit of failover, which meant that if you wanted to fail over an application, you had to fail over the disk. And that meant dismounting the file system and mounting on the side. And that took a little longer for failover. And you had to create one LUN for each instance of the application. So now, let's say with a VM was most interesting with Hyper-V, is that if you want to put 100 VMs on a cluster, you really want each VM application instance, right, to be its own unit of failover. That meant you had to create 100 LUNs. And that was pretty tedious. So what CSV allows you to do is consolidate it all, have a single LUN with 100 VHDs running on top of it. So let's do kind of a quick snapshot overview of some of the I/O synchronization that CSV does. So how do we enable? So here's the point here. How do we enable a NTFS, which is a non-clustered file system, to work in a distributed fashion? So CSV is a little different in that compared to a normal clustered file system, and then most historical clustered file systems always did their I/O synchronization storage side. So they did some sort of a locking mechanism storage side to control that when metadata updates were happening, it was only happening from one server at a time. And they traditionally did that through some sort of locking on the storage side. With CSV, we actually do all of our metadata synchronization server side. And we're actually forwarding metadata updates, and for each individual volume, we designate one node to own all metadata updates. So metadata updates being creates, extends, opens, all go and orchestrated through one server on a per volume basis. So if you had 10 volumes and 10 servers, each one could be owned by a different one, each one orchestrating for an individual LUN. Data, reads and writes, go directly to the disk. So reads and writes are direct, and metadata operations are synchronized. And again, when you're doing metadata operations, it's just the small, lightweight metadata operations. It's not the data payload associated with it. So if you're going and starting a VM, it's just the open, which goes over, and then the reading into the file goes direct I/O. So it's just very small, lightweight operations. And then we actually use SMB as a protocol between the nodes to do forwarding of I/O between the nodes. And I'll talk about why that's important in a minute. So I talked about a little bit this. So we have a concept of ownership. So an individual node we consider the coordinator node, which is the one that owns the disk. And so we use persistent reservations to control ownership of the LUN and fence it. Then nobody else can get to it but us. And then we create a namespace on all nodes. So we create the C cluster storage namespace on all the nodes, which allows all nodes to access the single volume and the single the file system. And so I'll talk about, we do two different types of I/O. So there's that what we call direct I/O, which is all the reads and writes, which is things that are going down directly to the disk. And then there's metadata operations, which are being redirected over SMB. We call them redirected I/O. So how do we actually implement direct I/O? So what we do is that we actually pin the file so it doesn't move. Then we go look at the extents of the file so we can actually understand where on the physical LUN is the file. And then we actually go and convert it, and we actually do raw I/O down directly to the offset to do updates to the files. So that's how we're doing direct I/O. We're actually kind of bypassing the file system in a coordinated way and down and updating the disk directly. So I kind of talked about this. So CSV, as it was implemented in 2008 R2, was first implemented as an upper file system filter driver. So it was an upper file system filter sitting way up at the top of the file system stack. It basically looked at I/O coming down the stack, and then it would decide what to do with it. And it'd look at it and go, oh, you're a metadata update, I'm going to forward you over SMB, or you're a read or write, I'm going to send you down directly to the disk. So CSV in 2012 has actually been completely written from scratch. And we actually did a lot of innovation, and a lot of it we did to make sure we had better interoperability with ISVs. So here's kind of a picture of what the CSV architecture looks like now in 2012. The most important thing I'm going to point out to you is, let's see, where's my pointer? Okay, so here's three nodes. So the node on the left, okay, so let me talk about the node in the middle. The node in the middle is the orchestrator. So this is the node which owns the volume. What you're going to see here is that there is actually a CSV file system stack here, and then there is the NTFS volume stack here. We actually put a filter up on top of the NTFS stack, and we keep it hidden. So you actually will not see the NTFS file system. It's actually hidden under the covers. And then we expose the CSV file system. You'll also see here's the node which is not the owner, and it has the CSV file system mounted, this kind of pseudo file system mounted. And you'll also see the CSV file system mounted here. So the difference here is that this node has storage connectivity, and this one does not. So that's kind of how I'm trying to illustrate this one and this one. So here's how the flow works of data, is that if a VM is being started, it will come down and it will touch the CSV proxy file system. And then if it's an open, right, we're going to call across SMB, and then we will actually orchestrate through the NTFS file system down to the volume. If it's once the VM is started and it's up and running, so if you think about metadata operations with a VM, they're actually incredibly small. They're actually very minor. So things like a VM, you start up the VM, and there's a little bit of metadata, and then everything is just all reads and writes to a big honking file. And then data flows down directly. All those reads and writes, once the VM is started and up and opened, just go down directly to the disk. So here's a failure scenario. So one of the cool things about CSV is that we also have failure handling. So we can actually handle, if you walked up and yanked all the fiber cables out of the back of the server, we will detect that. And what we will do is that if we detect that we have lost storage connectivity, we will actually go and start redirecting I/O, all the I/O, not just the metadata, but all the I/O, over SMB and through one of the nodes, and then doing the I/O on its behalf. So that way we can actually recover from complete storage failures. So what's one of the important things you as an app or a service, as an ISV, need to think about when writing on top of CSV? So CSV works very, very well. So if you were thinking about writing your app on top of CSV, CSV works very, very well for any app which is low read metadata, high read-write. So think about things like virtual machine, a database, your very low metadata operations, lots of reads and writes. Things like a Word file, right? High metadata intensive, low data. So you need to think about what is kind of the I/O pattern of your application, and think about as if it is well suited for CSV or not. So I think that'll help define whether you want to write on top of CSV or not. Because if it's extremely metadata intensive, like a Word doc, you're going to be doing a lot of I/O redirection. So you're going to be hitting here, going to here, and writing here. So it may not be as optimized as doing an application which is high reads and writes. Does that make sense? I get nods. Okay, we're moving forward. So let's do a component. Let's drill down a little more. So the different components. So if you look at the top, if you look at the CSV architecture, we have the CSV filter driver called csvflt.sys, which sits up, and it basically is creating the pseudo file system. And then at the bottom of the stack, you'll see we have the CSV vbus. And so this is kind of the pseudo file system stack. Why did we do this? So the problem we had in 2008 R2 was we were this upper file system filter. And either we sent things this way off over SMB, or we bypassed everything and wrote down to the class driver and then did our raw I/O. But we missed everything in the middle, right? We missed all those file system filters, all those volume filters. So if you're a backup vendor, if you're an antivirus vendor, if you have some sort of hierarchical storage solution, none of your filters could inject and interoperate with failover clustering, replication solutions. So now we have the pseudo file system stack, which we built specifically as an interoperability stack so that you can plug in your filters. So another thing to be aware of, so as I mentioned replication, one thing to be aware of is that with CSV is it's a distributed file system. So if you insert a filter on any given node, you're only given that node's view of the file system. So that's one thing to think about. So here's what I was talking about. Like if you want to inject a filter, where should you do it? So you can actually attach on top of CSVFS. You can actually insert yourself as a file system mini filter. You can attach a volume filter. We don't support legacy filters on the CSVFS stack. So the only real caveat is no legacy filters. And if you're like an antivirus vendor, so what we're doing is we're actually don't attach to MUP, because what we're going to do is because we're doing I/O redirection between the nodes, you're actually going to be scanning files twice. You'll scan it once when it comes in, you'll hit it on top of the file system with your filter, then we might do some I/O orchestration between the nodes, and then you're going to hit it when we go send it on the wire for SMB. So you'll be doing double scanning, and that's not optimized. So that's one thing if you're doing any sort of scanning of SMB traffic, make sure you're not double hitting the files. So CSV, I talked about that it appears as a proxy file system. So you go and format a volume. It will show up as NTFS. You will format it. You get your NTFS volume. You can take things in and out of CSV. Under the covers, it's still NTFS. When you enable in 2012 a volume to be CSV, it will now show up as CSVFS and actually has a different file system identifier. We do this for a very specific reason to help enable you, ISVs and OEMs and IHVs, to integrate with CSV. So we want you to know you're running on top of CSV. So here's the problem we had in the past. Was in Windows Server 2008 R2, we made CSV appear as an NTFS volume. We worked really hard to make it look and act just like NTFS. But there are actually some caveats and some differences. The reason is that we are actually doing this metadata orchestration through SMB. So even though CSV looks like a local file system, in some semantics it actually behaves like a remote file system. So some apps will actually have different code paths, whether they're running over a local file system or a remote file system. And so we want to make sure you're aware of what you're running on top of. So we didn't want to try to do smoke and mirrors and fake it out and make it almost look like NTFS, but not quite. So our goal here is to enable you. You will know if you're running on top of CSVFS, and you can either explicitly opt in or opt out if you don't want to support it. Additionally, if you have a filter that wants to attach to CSVFS, you now have to attach to the right file system type, right, to attach to CSVFS. So if you just have your traditional filter, which is not CSV aware, and you just install it, it's going to go try to attach to that hidden NTFS volume. It's not going to attach to the CSVFS volumes. So just a heads up for anybody who's got a file system filter. So here's the namespace. So we actually build this single namespace across all the nodes in the cluster. So the goal here is if your app, you're writing an app which is going to run on top of CSVFS, it's just going to be under the C. Under C, we create a directory called cluster storage. And then under cluster storage, we create mount points. We basically create one folder for each individual volume, and then we just create mount points between them. And we keep them consistent across all the nodes in the cluster. You can rename them. If you rename it from volume 1 to like my app's data, we will rename it across all the directory structures across all the nodes. So the key thing here is that when you're building your app, you just point it at C cluster storage, whack, blah. You will actually have distributed access from any node in the cluster to get access to the CSV volume. So that's all you have to do is just stick it in the CSV namespace, and that's all you have to worry about. It's under C cluster storage. So here's what I was talking about. So CSV appears as a local file system, but actually we deliver some behavior remote file system. We've actually published an API compatibility guide, and actually this guide breaks down NTFS, REFS, and CSVFS. So it's a big long list of all the file system APIs. So the goal is that you, if you want to support CSVFS, you can basically go look at the API Compat guide. You can say, what are the different file system APIs I call? You can look at the guide and you can figure out what are the semantic differences between if I'm running on top of NTFS or REFS or CSVFS. Storage. So I talked about earlier, there's this giant misconception that in order to set up a cluster, it requires some $1 million fiber channel SAN to set it up and get it working. And that is not true. You can achieve high availability with failover clustering at a low total cost of ownership with commodity storage, which is available. And so there are a number of options available. So the one on the left is the one everybody always thinks about, the fiber channel SANs. Where's my pointer? Oh, I put my finger over it. There we go. The fiber channel SANs, that's the one always everybody thinks about, but you can do low-cost iSCSI, FCOE. You can do SAS RBOD is something we're supporting in the future, spaces on top of normal JBODs, SMB support, and even the hardware replication. So the replication vendors support integrating with failover clustering. If you want to do replicated storage for disaster recovery, whether it be EMC with SRDFCE or HP with their CLX solution, they all integrate in and can provide hardware-based replication solutions, software-based replication solutions. So if you don't want to have shared storage, you have a requirement not to have shared storage, we have tight integration with many vendors from DoubleTake to SteelEye to Symantec to Neverfail, they all integrate. And then there's also application-level replication. So things like SQL Always On, Exchange, database availability groups, they all plug in and they can provide application-level replication. So my key point here is clustering does not require big, special, expensive hardware. Commodity stuff works. And there's many solutions available. So what are some of the things that have changed in 2012 which you should just be aware of as if you are a storage developer or an OEM? So persistent reservations, I already talked about that. We have the SCSI inquiry data is now required. It used to be recommended, now it's required in 2012. And then we have that one new read command, but we only use that for spaces. So if you don't care about spaces, then you don't have to worry about it. There's some new control codes if you have your own custom resource DLL for replication. So if you're a replication vendor with your own custom resource DLL, we have some new control codes you need to support. Our backup story has changed significantly. So if you are a backup vendor, I could do an entire hour presentation on how to integrate with CSV and what the backup story is. But there's significant changes, and come talk to me later. I can send you cards and decks and all kinds of stuff. So the file system identifier, we talked about that with CSV different. And for replication vendors, we now allow third-party resource DLLs to insert themselves into the CSV groups so that if you want to have your resource DLL live in the same group as the CSV volume so it can move around with the CSV volume so you can control replication. When you flip the replication underneath the CSV volume when we move it around, that is now supported. And I have a doc on how to do that. Here's just a quick snapshot on some of the backup changes. So backup was kind of was one of our challenges in 2008 R2. So now we have improved I/O performance. So we actually do direct I/O with software snapshots. So in 2008 R2, if we had hardware snapshots, we do direct I/O, but software snapshots were in redirected mode the whole time. So now we do direct I/O with software snapshots. We support parallel backups now on the same LUN from different nodes or from the same node or different nodes. And we have much better interoperability. Before we had a big long set of APIs which you had to support to interoperate with CSV. So let's talk about making apps highly available. So first thing is if you are an ISV and you are thinking about integrating with failover clustering, what are the APIs available for use? We have a native cluster API, so we have our cluster API. That's probably that's one of our core that's been around for the last 10 years. We do have a cluster WMI provider, which is kind of our recommended if you want to write a management tool, I would go with WMI. Just to warn you, Can't really talk about futures too much, but we're looking at a WMI v2 provider, and I just want to say this is something we're looking at and we may be coming in the next release. So if you go off and write a whole bunch of code in a WMI v1 provider, that you don't show up all pissed off when I show up with the v2 provider. So that's my little disclaimer. Let's see what else here. We have a COM API. We have a MS Plus COM API, which we deprecated back in 2008. We still ship it, so your code will still work. Please don't write any new code on it, because it's going to go away someday, and it's actually one of the changes in 2012 is that our COM API is actually not installed by default, so you have to install it. So it's there, just not installed by default, and you have to add it in. Actually, if you try to install a legacy version of SQL, non-SQL 2012, on top of Windows Server 2012, you have to go add this in because they actually have dependencies on the old COM API. They removed them all in 2012. So if you have an app, so that's my key warning here, if you have an app you wrote using the COM API, you install 2012, boom, suddenly it doesn't work, please go remove them sometime in the future. Optional component, you can put it back in so you're not totally broken. Make sense? Okay. So let's talk about UIs. So failover clustering, we have a MMC snap-in called Failover Cluster Manager. We do allow extensibility into Failover Cluster Manager. In the past, so there's a little bit of confusion about this. Back in Windows Server 2003, we had all kinds of extensibility in our GUI. You could put in custom pages here, and custom that there, and tweak and put in all these dials and knobs, and we thought we built this, and a lot of effort was put into building this incredibly extensible, amazing solution, which we thought was going to be great. And then nobody used it. So a whole lot of dev effort wasted. So basically we cut everything out, except the one thing we left behind is we do allow custom resource property pages. So if you write a third-party, if you write your own resource DLL, you can actually have a property page to allow customizing and configuring the attributes of that resource DLL. So that is still there. That is still supported. It's still supported in 2012. It's been there since 2008, 2008 or also supported in 2012. But actually in 2008 we supported all the other stuff. Nobody really noticed or cared, but the one thing we still support, which everybody does care about. PowerShell. So in 2008 R2, we switched our command line story. So in the past, we had a command line story built on top of our cluster.exe executable. In 2012, we switched that to now doing PowerShell. So we actually have parity between cluster.exe and PowerShell, and we've actually deprecated now cluster.exe. We deprecated in 2008 R2, and we replaced it by PowerShell. I talked about that. It is also an optional component, just not installed by default. You can go and add it. You just do install Windows feature, and you can add it back in. It's also exposed through the GUI through Server Manager. So the one thing I want to talk about this is that there's actually people who have actually written code wrapped on top of cluster.exe. I'd probably be using one of our APIs if you're doing that, but cluster.exe is still there. If your test infrastructure, you may have scripting which is built on top of cluster.exe for your test infrastructure. Again, it is there. You just have to install it. It's not installed by default, so it's an easy fix. Actually, let me show you. Oh, here we go. So go in this, I'm just deviating for a second. So if you go into Server Manager, and you go add and remove features, pick this node, and you go to features, and you go down here under remote server and admin tools. You go under features, failover clustering, and here you'll see it. So you got our COM API, you've got our cluster.exe tools. Simply check the box, hit next, boom, you got it back installed and you're running. So very easy to add this back in. We got nice GUI ways to do it, just not there by default. Okay. So my deprecated list. So this is just my heads up for all of you as ISVs. What are some of the changes? We talked about cluster.exe is deprecated, not installed by default in 2012. We talked about the COM API, deprecated back a couple releases ago, not installed by default. In 2008 R2, we also dropped support for 32-bit resource DLLs. Still will work in 2012, but again, deprecated at some point in the future, we will remove support. And I guess, and a heads up that I talked about this already, we got a V1 provider we wrote 10 years ago. We're looking at a V2 provider. So if you write some new code a month from now, you don't come and stone me. So, all right, so let's talk about how to enable your applications for high availability. There's kind of a couple different things you can do. So let's say you have some app, homegrown app that you wrote. You got some homegrown service. How do you make that highly available? How to use failover clustering to achieve that? There's kind of 3 different ways to do that. And I call it kind of the good, the better, and the best. So with good, you can use our generic app or generic service, no changes to your app or service of any kind, and we will make it highly available and make it failover from server to server. The next level up is our Gen script resource, which allows you to get some customization on the health monitoring. And then the next one up is writing a full-blown resource DLL in C. So let's talk about Gen service. So Gen service, again, is a resource DLL that we ship built into failover clustering that enables you to make any service highly available. Basically what it does is it just calls netstop and netstart. So basically what it's going to do is, what is if I want to fail over a service from here to here? We're basically going to call netstop here, and we're going to call netstart here. That's basically what failover is. So if I just simplify it. The health monitoring, it's very simple and easy to configure, and the health monitoring is very lightweight. So basically all we're doing is we're querying Service Control Manager to check the health of the service. So nothing fancy, we're just going to catch if the service crashes, we detect it through Service Control Manager, we'll restart the service and move it to another machine. So very lightweight, but very easy. So it doesn't provide great application health monitoring, but it does provide you resiliency from things like the storage, somebody yanks the power cord out, motherboard dies, lose a power supply, hard drive fails. We're going to move that over to another server. But again, it's really lightweight and really easy. Generic application. So the one solution allows you to configure services. This allows you to configure executables. Again, simple, easy, no changes. You can throw your app, you can have a CSV volume, put your executable out on the CSV volume so all nodes have access to it. And then we're just going to start the process here. And if this server crashes, we're going to start it up over there. Gen app. So Gen app also does very basic health monitoring. It's just monitoring the process ID. If the process ID goes away, we detect it's crashed and we start it up on somewhere else. All right, so let me show you. Death by PowerPoint. Let's see what this thing looks like. Okay, so what I've got here is I've created a simple 2-node cluster. If you want to create a 2-node, okay, so let me talk about this really quick. If you just want to do a proof of concept, you can do it with nothing special. You can have 3 laptops, 3 desktops, single network connection, nothing fancy, standard desktop hardware, nothing. Or even a single machine with 3 VMs. Here's what you do, is you're basically going to install Windows Server on machine 1, install the failover clustering feature. You're going to install Windows Server on node 2. This is what my Office cluster is that I'm showing you right now. Just a standard desktop machine, Windows Server installed. On the 3rd machine, you're going to install Windows Server, and you're going to install the iSCSI software target, which is included in Windows Server. Right? And then basically that's going to emulate being an iSCSI storage array, and you can present it to those 2 nodes. So if you want to go home and set up a nice proof of concept to see if your app can work on a cluster, you can do it with no cost, nothing, just VMs, desktops laying around, whatever you got. So if you want to go try this out, there's nothing, no barriers. All right, so let me show you. So the first thing you do is I've created this 2-node cluster. So here's my 2 nodes. And then I click on roles here, and I'm going to say configure role. And so we've got wizards that set all this up for you, is the short answer here. Is we've tried to make this as simple as possible. So the first thing I'm going to do is I can set up a Gen service. So I'm going to say create. So basically, let me step back. We give you a list of things to create. You'll see Gen script, Gen app, Gen service. I can configure DHCP for high availability. I can set up virtual machines, a lot of different things. So I'm going to make a Gen service. So we actually go and enumerate Service Control Manager and display all the configured services. So what you would do is install your app, install your service, get it configured the way you want it. Then you run our wizard. We'll go query Service Control Manager and look for your service. I'm going to pick something here fairly harmless. I'll just pick that for fun. The next thing we do is we're going to prompt you for a name. So what we will actually handle is if we will handle binding and unbinding IP addresses and names associated with that app or service. So basically think about it, well, if you want to call it, when users what are users going to use to connect to the service? And then what happens on failover, we will actually unbind the IP and name, and we'll go over to another server and we'll bind that IP and name. So it's kind of transparent to clients where this service actually lives. So I'm just going to include, I don't know, make something up. The next thing we'll do is we're going to ask if you want to put some storage in with it. If you want to use storage which is dedicated that fails over with the app, then you do this. If you just want to use cluster shared volumes, don't have to worry about it. So cluster shared volumes will be available to all nodes all the time. This is if you want to stick an individual disk in the group with it. So you could pick a disk if you wanted to. So here, I'll pick a disk, just for fun. The last page is we're going to say, hey, do you have any other registry keys associated with this service that you want me to replicate for you? So if you have, under HKey local machine, you have some configuration state associated with your service, and what we will do is this is a way that any other thing, we will grab it, take it as a blob, stick it in our cluster database, and replicate it across all the nodes, and make sure those keys are consistent across all the nodes. This enables you, again, I was talking about if you have a 64-node cluster, you only have to configure your service once on one node, and we'll push the state out across all the nodes. So we're trying to make it simple for you. I'm going to skip that. And then says, hey, here's what you're going to make. And off I go. And that's it. So now if I look, here's my generic service. And you can see it created a name for me. It created some IP addresses for me, which are associated with that. Since I have IPv4 and IPv6 enabled, it created both IPv4 and IPv6 addresses for me. Went out to a DHCP server, pulled down IP addresses, and I've got my storage connected here. So let me show you this. So the question was around, is it just registry? Do we just replicate registry, or what about data? So data, we only do registry. We only will push around registry state. If you had, you could put it out on the shared storage. You could put it out on like the CSV volume, and all nodes could read in the file state across all the nodes. So let's see here. Where was my... Okay, so here's my print spooler. It says it's running. So if I look at this, so here, let me see if I can do this a little more interesting. Put this here, put this here. We'll slide this over. So here you see, here's my print spooler resource. And it is running on node 2, which is the node that I'm on right now. So if I go here and I just say stop, so you can see the resource goes into, into an offline state. Let me move this over a little more. So what does that really mean? So if I go over here and look at Service Control Manager, I do a refresh, you'll see the service has stopped. So if I just stop, and then if I start, and I go over here, do a refresh, we're just doing net stop, net start. Make sense? So what does failover really mean? So failover, if I want to fail this thing over, I can say move, best possible. So now you can see I'm actually transitioning it from node 2 to node 1 here.
You used to stop a generic application. Do you do that now? Application stop.
Yeah, so we basically called net stop the Service Control Manager on this node, and then net start on this node.
Generic application.
Let's talk about GenApp. Okay, you're one slide ahead of me, one demo ahead of me. All right, let's go here. So let's create GenApp. Configure role. Let's do GenApp. Again, now it's going to ask me for the path to the executable. We are going to make the most important app in the world highly available. We're going to give it a name, what clients are going to use to connect to when getting to this app. If I want storage, I can again throw storage in, or if it's CSV, I can just throw the executable and all the data out on the shared storage. Boom, there we go. Oh, finish. Almost thought that was the end of my demo. Okay, so here we go. Here's my Gen app, and you can see here is Notepad. And if I bring up Task Manager, Where is my Notepad process? Notepad, here it is. So Notepad is up and running. So the app is up and online. So what are we actually monitoring? So let me show you this. Let's simulate an app crash. So I can actually right-click on my, let me do this. I'll do like an end task. So boom, you see how that? We detected that we did an end, that was like super fast. If you blinked, you missed it. So I'll do it again in a second. So what I did was I just did an end task on the Notepad process. We were monitoring the Notepad process. We saw that the process went away, and we restarted it. I'll do it again. Let me find it again here. So here, I'm going to do an end task. And so now you'll notice that the Notepad process, where'd the Notepad process go, right? So if I look, what actually happened is that it failed over to the other node. So our failure policies, so here's the way our failure policies work by default. Everything's customizable, do whatever you want to do. But by default, if an app fails once, we'll attempt to restart it once on the same node, because we view that as a lightweight recovery. If it fails again, then we go, oh, something's wrong with this node, we're moving it somewhere else. So that's what we did, is we fail over Notepad.
The question, though, is if you take the resource offline, does it kill the app?
Yes. Let me fail this thing back. Move back. So now I'm back on node 2. You'll see my Notepad process just popped up. If I go and shut down, Notepad goes away. We shut down the executable. Okay. So we'll shut down the process. Let's see. Let's do GenScript. Oh, I haven't talked about GenScript. We've got to get to those slides first. Yeah. Yeah, so great question there. So I'm storing my data in like C program files, and I want to have them available to all the nodes. So yes, you'll be able to. So that is actually one of the changes you might have to make in your app, is that you'll need to allow defining a different path for the executables if you want to put them on the shared storage. So that's the one thing. You may have like a hard-coded, we only support under C program files, and you don't expose to users. But you'll have to expose some mechanism to allow users to change the directory paths. It's just monitoring, so it's only basically going to catch if the process crashes. So it's doing very, very basic health monitoring. Is the process there? If the process goes away, then it goes and restarts it. So now we're going to talk about what does it take to do better, right? Because that's very basic. That's what you get like for free. Now let's talk about how do we get better. So we have, you can do more verbose health monitoring. So like, for example, we have what we call these is-alives and looks-alive entry points, which you can be called, which basically do different things to the app to check it. So for example, let's talk about SQL. And they're in different intervals. So a looks-alive is very lightweight and happens every 5 seconds. An is-alive is more verbose, more checks it, a more deep check to make sure that the app is actually functional. Let's use SQL, for example. I'll use like SQL 2005. SQL 2005, it's a little different in 2012, so I'll just use the legacy SQL. SQL 2005, like when it would go do the lightweight health check every 5 seconds for the looks-alive, it would just look, query Service Control Manager and say, is the SQL process up and running? Basically, it would check, has the app crashed, hard crashed, for a recovery mechanism. Every 60 seconds, it would do a more verbose check. It would actually do an add server name T-SQL query into the SQL instance. So what that would actually check is the app not only just there, but is it actually functioning to clients? This is actually the most interesting question, right? Is that what is the definition of down? The definition of down is when a client can't get to it. So if the process is still up, but you have some hang which has caused the app to become unresponsive, it's technically down, but we won't detect it with the GenApp Gen service. You really have to implement is-alives and looks-alives to do app-specific queries or service-specific queries to actually see what is your definition of up and working. Make sense? Yeah?
So what's the monitoring frequency of the GenApp Gen service?
It does the same thing, 5 and 60 seconds, but the checks are the same. So every 5 seconds, just saying. Actually, for Gen app, it actually will notice that the process dies instantly. So we actually get a notification the process dies and we recover instantly. That's why that was so fast on that demo. But a Gen service would be every 5 seconds. Okay. So GenScript. So GenScript, you can implement all the different entry points and get more verbose health checks. So the big difference between, what is the difference between a GenScript and writing a resource DLL? Here's the big difference. With a resource DLL, you can do more powerful things and very, very elaborate, powerful things. Most heavy, serious, like for Hyper-V, we have a resource DLL, SQL. They all have file server, their own custom resource DLLs. But a GenScript is going to allow you to do that in a much lighter way that you don't have to write a full-blown resource DLL in C. So it's just an easier, cheaper way to do it. What is the trade-off? User experience. So with GenScript, you've got to write a script. And then the user is responsible that he's got to go copy this script to each one of the nodes, right? And if you add a new node to the cluster, you got to copy that script to the node and you forget it. And you update the script and then you have to make sure you update it across all the nodes. So it's just a little more tedious. I view it as, if you're going to be doing a first-time prototyping, you do you're going to do Gen app, Gen service for your proof of concept. As you evolve a little more, you might do a GenScript, and then you get that better health monitoring, but you're probably going to put some tax and tediousness on your IT admins. And then as you evolve, you might do a full-blown resource in C. So that's just kind of the difference. So here's the different entry points. So basically, open initializes. The interesting ones here, open is the starting. I'd say online is starting, offline is stopping. Terminate, which basically means shoot it. Like that's a very fast recovery saying something's gone wrong and we need you to shut down now within a few milliseconds. And then isalive, looksalive are the interesting ones, and that's where we're doing these health checks. So let me show you. So here is, let me flip over. Let's do a quick demo. So GenScript. So you can do the same thing. You'll do GenScript. You'll just define the path to the script. I've actually got a script here. Actually, in the sake of time, I'm going to kind of move a little bit fast through this. So here I've created a script, and I basically implement the different entry points for open and online and offline. This actually doesn't do anything fancy. Here's close and terminate. It doesn't do anything fancy. Actually, this is a VB script to make Notepad highly available. And so you just specify the full path. So here would be C GenScript. So you put the full path here, and then it creates it for you. So let me show you once it's done, just in the sake of time here, because we're almost out. So here I've created one in advance. So here's my GenScript. And here I can see it's pointing at my C GenScript. And here's my GenScript VBS. And you can bring this online. Where's my task manager? And here's my Notepad process. So it's doing the same thing. It's just making Notepad. It's just another way to make Notepad highly available. But this is just, you could do custom isalives and looksalives to really actually verify not only is the app there, but is it actually working? That's the most interesting question. Writing a resource DLL. So we have a big, long blog series on how to write a resource DLL. This could be a whole long talk in itself, but we've got, I think, some pretty good stuff out there for you. If you want to write an actual resource DLL. And you can do very powerful things in your resource DLL. But again, it's the trade-off, right? Higher development cost, easier for admins. GenScript, super easy development cost, harder for admins. So it's all a matter of, as you kind of evolve your HA story. Another thing is that there is an evolution kind of going on in customers' expectations from what I will call high availability to continuous availability. So people's expectations are now they want things to never go down. It used to be in the past that if you yanked the power cord or if you want to move things from one server to another one, having a little downtime was okay. Now customers don't even want that. For example, Hyper-V live migration. There's actually a little downtime when you live migrate a virtual machine from one server to another one. But the reality is that TCP reconnects actually makes it totally seamless from a client perspective. So we're actually, what we do is we transfer all the state from one server to another one, we get everything all ready, and then we quick do this cutover from one to the other one. And because we keep it within the TCP reconnect window, it's seamless from a client connection. They do a TCP reconnect, all of a sudden they're redirected from one server to another one. They never realized you moved that virtual machine around. So customers are now expecting that more and more and more through workloads. We also, in Windows Server 2012, took the file server story to the next level. It used to be that if you had a Windows file server and you failed over that file server, we basically did net share and created a share on this server. And when you failed over, we deleted the shares and called net share on this one, net share add, and created the shares over here. And you basically just switched from one to the other. Client sessions were broken. Clients had to reconnect. Seconds of downtime seemed okay. Now, when we started thinking about one of the new things we support in Windows Server 2012 is about using file-based storage. So when we started thinking about you're going to create some 64-node Hyper-V server with VMs connecting over SMB against a Windows file server, suddenly it's really bad to fail over this VM from one host to another one and break all those SMB sessions and have those 8,000 VMs come crumbling down. So now we needed to evolve our story to keep the SMB session state replicated across the nodes in the cluster and to make it seamless. My key point here is that even if you implement, you need to be thinking about continuous availability, the next evolution, kind of the next level of beyond even high availability and failover. All right, so I threw this slide in like 20 minutes before this session started because I thought that was interesting and I had a good conversation. And I'm almost done. This is my last slide, and I know I'm over by about 30 seconds, so I'm almost done. Let's say that you have your own homegrown app or service. My key point here is that with the infrastructure built into Windows Server 2012, if you go home and your boss says to you, what's our HA story? What's our DR story? You have an HA and DR story for free, for nothing, that will work with your app guaranteed. What do I mean by that? You can use virtualization. You could take your DOS 622 app that's laying around that nobody can find the source code, and you know you're not going to innovate to make work on top of a cluster, and you want to make that highly available. You can throw that into a virtual machine. I don't even know if DOS 2.2 works on top of Hyper-V, but it sounded fun. So you can throw that in top of a VM, and failover clustering can make that virtual machine highly available. So if that server crashes or hard fails, we will fail over the VM and all the apps running inside the VM. So there is 0 changes required on your behalf. You can have an HA story. So if you are selling a solution and you have customers coming to you saying, what's your HA story? You can say, throw that app in a VM, make that VM highly available, and you have an HA story. Let's talk about disaster recovery. Your boss says, what if the data center gets taken out and we need to have some story to move to? What is our disaster recovery story for this DOS 622 app? You can have one for free. We have a solution built into 2012 called Hyper-V Replica. Hyper-V Replica does point-in-time replication. Every 5 minutes, it takes a delta of changes and pushes them across to the other site. Disaster recovery built in for virtual machines, it is free. Hyper-V Server, the free SKU, includes high availability and disaster recovery built in for free. 0 changes to your apps, 0 changes to your service. You have a story, you just don't know it yet. So if you do nothing else, if you decide, I don't know if I want to go write a gen service, gen app, gen script, resource DLLs, blah, 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 go do this, at least you have a story. Okay, and with that, I'm done. So I just want to say the lowest total cost of ownership, standard edition, you don't need special hardware. You can make apps and services highly available with little to no changes to them. We have a story that evolves and can do very, very powerful things if you want to make the investments. I'm going to be at the thing down the hall, so if you want to ask more questions later, I'll be down there as well. And with that, any quick questions? Let me ask that. Yeah.
So if you have an application that has multiple services or processes, is the script or the resource the best way to handle that?
Great question. So the next question, so what I demoed and what I showed was really about having an active passive configuration where basically the service only ever ran a single instance of the service and a single instance of the service failover. What if you have a multi-instance service? SQL is a great example of that. Single service, multiple databases, multiple instances, and failover. In that case, you're probably going to need to write a custom resource DLL to be able to handle the instancing because you're not just going to call, like gen service just calls net, unless you want to have multiple instances of the service, which I doubt you want to do. So then you're probably going to need to write a resource DLL. But that's like what Hyper-V does, because they actually call in the VM of service and start individual VMs, and that's what SQL does. And
with a resource manager, you can say, try just starting with one. If one process dies, you can try just starting that one. If that doesn't work,
yeah, well, yeah. So in the online routine can be whatever you want. And that would be defining calling into your service and calling the individual instance. And then what would it mean to, if things fail, to fail them over? Yes. Okay, with that, thank you very much. I know that was a lot in a short period of time, and you can catch me at the, I don't know, whatever the thing is down the hall.